Hey guys, I'm Sam with Scrappy Industries. Welcome back to our 1944 Cleveland engine revival. Now, in the last video you guys saw, we finally were able to get this thing running. Our next task, let's start checking up on the generator. We also have a lot of small little tasks to do here, but I kind of want to check a few things on the generator and see what we got. So I 100% misspoke a little bit in our last video, and I appreciate some people calling me out on this. I've done a little more research, a little more learning on exactly what we're doing. Kids, what are you doing? So the armature A1 and A2, that's the power that this thing is actually generating. The field, which we have F1 and F2, so A2 and F2 are a common tied together. That's what we have to put power back in to create the magnetic field inside of this so it can generate more power. So the way that this thing needs to be wired up to be able to regulate itself is we'll have to have a rheostat that can take some of the power generated at A1 and push it back into the field at F1. And looking at the manual, they are wound up today. So looking at the manual, the rheostat needs to be able to go up to basically like 150 watt capacity. What I calculated out, we'll need somewhere between 50 ohms and like 120 ohms. And the max output that we need is 1.1 amps through the field on the exciter. That will create about 96 volts DC that we'll need over here on the rotor, basically creating the magnetic field on the main generator. So even though it says 120 volts, that's kind of like max output. We shouldn't need to go that high, but we're gonna need to wire up a little control panel with the rheostat. We'll put a voltmeter in there for the main generator, because that's essentially what we're regulating, and that depends on load. So if there's a lot of load, you have to turn this up higher than if there's a little bit of load, you'll turn that rheostat down. Now, how much we'll really load this thing, I don't know, but that's the idea anyhow, is there's a pretty good variance there on how much power you have to put through versus how much power you're using. And I find that interesting in that it's basically fully manual regulation, I believe, the way it was originally, and maybe the ship's load was very consistent. Today we have automatic voltage regulation, of course, on generators. They'll kind of absorb the load, try to maintain, say, that 480 volts, whatever your system is, where this guy does not do that. It's fully reliant on you on the little rheostat dial to keep the voltage where you want it. So in order to test if the windings are good, if the windings have any shorts, I purchased this Megger, we'll call it. So what we have the ability to do with a Megger is we can send out anywhere between 125 and 1,000 volts and check basically what the resistance is and see is the insulation okay on these windings. So what I'm going to do with our Megger here is we're going to test each of the windings to ground. So I've connected the one lead to ground, and we can kind of verify that we have a ground by putting the other one, because everything's pretty rusty. This should be a real low reading, yeah. So we're only getting 0.002 mega ohms. So we'll go ahead and stick this on armature 1. So that's going through one of these sets of brushes and into the armature, which is this part here, and into the rotor. We hold down test. And you can see we got 18 mega ohms, so a lot. It's not shorted. We'll do it again on armature 2, and basically these two are connected, so this should be the same reading, more or less. Yeah, very close. And then we'll check the field on the other side. And because these are tied together and these are tied together, really checking any one of these, I believe, is going to tell you that it's not shorted. Yeah, so 14 mega ohms. Basically, it's a lot of resistance that we're not touching ground. So that's good news. Nothing in here is shorted to ground. So these two wires here are where the exciter is essentially making the power to go to. They plumb up through here and through these two brushes, and they run in here to the center on the rotor, and basically there's windings around different iron cores. And the current going through those wires creates a magnetic field, and then that whole rotor's spinning. The field winding on the main generator is out here, and this is where our 480 volt three-phase comes from. There's no brushes here because it's wired out here in basically the chassis. So I was checking resistance just with a regular multimeter, and you're going to see very low resistance between these three leads because they're more or less connected in the windings, but they're all basically 0.1 ohms. The next thing we can do is check from where we're putting in our exciter voltage, check these to ground, make sure they're not shorted, and then we'll also check the windings of the main generator to ground and make sure that everything looks good there. I'm going to clip that guy on M1. And again, we need a decent ground. Yeah, 14 mega ohms. And that means that M2 should be close to that. Yeah, 12. All right, good news there. All right, so what we're going to do now is test our main generator windings to ground. Do it the same way. Again, let's check our ground reading here. I'm going to put this on 1,000 volts now because we're on a 480 volt system. Just to test our connections. There we go. 0. 3.2 mega ohms. There's kind of a residual charge in there. I think you want to hold this on and let it dissipate it. And 3.5 mega ohms. So I want to do a little research on these readings we're coming up with, but I think we're just Jim Dandy and safe with these to say that nothing is shorted in either the main generator or the rotor of the main generator or the exciter. So that's all good news. We're going to need to set up basically a little junction box here. Probably put some lugs on these that we can wire to. I wish that we had a little more length here, but you know, don't we all? This is where the DC would have been able to connect from the DC generator here. So we're not going to use these at all. Probably just unhook these. The brushes are also removed on the DC generator, so nothing's connected to that anyway. But we are definitely going to need to feed our exciter voltage in here to M1 and M2. Again, I'm not sure what that means. Magnet 1, magnet 2. Not exactly sure what's meant by M1 and M2, but that's where the exciter will hook up to. We need to wire up our little rheostat and essentially a regulation circuit on the exciter. That way we can control how much current we run through the exciter's field to control the exciter's output and therefore control the voltage coming out of the main generator. So those are all little things. We're going to have to come up with some parts, build some things, and yeah, we'll work on that going forward. Let's start working on our fuel system and fixing some leaks, making some gaskets, and just kind of general improvements on the engine itself. So when we were running this engine, we didn't seem to have the governor working properly, and well, I think it's stuck here. I have yet to take this cover off, so let's pull that off and see what it looks like. From my understanding, this actually has its own oil reservoir. This does not use engine oil, it has its own. So if I had to guess, there's some water in there and some rust in there, and well, let's see what she looks like. It is some sort of hydraulic governor. This is your speed adjustment over here, and everything there is working nice, and it's not stuck or anything like that, but let's check it out. I don't know how long it's been since it ran, but it's been a long time. If it needs to lift on that guy, because that's all of it. Wow. Some very precise looking stuff happening in there. Fortunately, it's dirty and there's some rust down towards the bottom, but it doesn't look hateful overall. I feel like we're gonna have to do some tear down and clean up. Okay, so turning that knob there on the front, that's what you're doing. It's just essentially a gear reduction. This also has some wires coming in the bottom. so I'm not sure if this thing could actuate itself. I would kind of doubt it, but I mean, anything's possible. That's one of your oil adjustments. Probably determines like how fast it can catch the load, things like that. I think those are your flyweights going out and pushing up then on this guy. I'm kind of curious what these wires are doing in the Governor. I don't know if they're like an indicator, if it's running or, you know, something like that, if it's at speed. I don't know. Let's see what we find in here for connections. Oh, no way. Could it vary the speed remotely? $115 volts. I'm not sure if that's a motor that could turn this thing for you, or if that's just a solenoid. Yeah, RPM 10. Huh, so it's got a gear motor. Look how good a shape it's all in, a Bodine in Chicago. So basically they could remotely change the RPM. So they probably had a little frequency meter somewhere remote and they could either manually or automatically adjust the Governor. Very cool. Did not expect to see that. So it's 100 volt AC, it looks like. We got a little sine wave there. Cool. Hopefully this doesn't destroy anything. Just a little bit of taps. Probably be smart to clean this up as well as we can before we jam it in there. So after tapping on this guy, we got it freed up a little bit. I really think the smartest thing to do here is just take this clear off. I think that it's going to save us aggravation if we just kind of get it on the bench, tear it down, and make sure it all functions properly. Looks like all we need to do is take these 4 cap screws out, or those studs. Oh, those are studs with nuts, either way. Pull those 4 nuts off, and I think the whole Governor will lift off there. Fortunately, everything's been well lubricated on this. We had a lot of oil coming out of this Governor, and I'm not sure why, as soon as we started rolling it over. So I don't know if there's a crack or a leak or what exactly I have going on, but that probably needs to be addressed as well. Maybe we can pry right there. And she's out. Yeah. That is a serious Governor. Yeah. Oh my. A little bit of straight water. Might be why she's stuck. We'll give that a minute.
What happened? Did you lose a tool down there?
So we got the Governor off and I was just cleaning up. This does confirm what I was showing earlier, that all of this is brass, and so are some of the inner parts here are brass as well. I think that's really neat. I'm wondering how we can clean all this up. I think it could look really cool just to leave it as brass when we redo this thing. That's where the Governor goes. I don't think we have any catastrophic issues there. I have the Governor dripping out over here into the waste oil drum, even though it's mostly waste water. Then we'll get it cleaned up and start taking it apart and freeing everything up. I'm going to try to remove these 4 socket head cap screws, and I think this will come off, but I'm not real sure about that. There we go. We can get some of this cleaned up maybe. Oh, look at that. Let's pushing this in, pulling out. So that's the stop position, I believe, and that would be full throttle. Well, I don't know if this part will come off or not, but I guess there's one way to find out. Dig any of that crud out of there. So looking at the way this is made with that gasket there, I'm pretty sure this whole top part has to come off before we can take that off, which is with as much water and rust and everything as I see down there. I think we really need to take it all apart and clean it up. I think you can reach down in there with a flathead and get that side. Same thing on this side. So that may lift off of there actually without too much trouble. That guy loosened right up for us. I have a feeling this linkage is going to need to be unhooked here as well. No, I guess not. This whole thing is seeming to come apart. Alrighty. Make sure we have this on film so we can put it back together. So I guess the answer is yes, we do want to disconnect that. So we have a prayer of reinstalling it. But I think down here lies what we want to really get cleaned out. You can see all the rust and poopiness and corrosion here. Got all that oil coming out of that passage now. So now that everything's cleared out of there, I think we're good to remove this control cylinder here off the side. Boy, they really had that glued on there. I'm not sure the best way to take that apart. I notice there's Allen, socket head cap screws all along the bottom here. We'll take this flange off of that. Oh, this poor thing. I don't think we can mess this up, but I don't really want to find out the hard way. So this passage we had lined up with this area here. And I'm sure we'll be able to see this even after we clean it up, but that's what it looks like. For our own reference, if nothing else. I'm impressed and happy that this stuff is in as good a shape as it is from being underwater. Look at that coupler. There's rubber. It's like a little miniature Lovejoy. And that keeps it all lined up. That kind of gives us a nice shock absorber. That's what drives the flyweights. Not sure exactly what we have over here, if it's some sort of like a pressure relief or something. These might unscrew, if I had to guess. It'll unscrew out of there. Oh, there's some big springs in there. And a broken spring. And a poopy spring. That's going to be fun to get this all back in there. Well, trying to avoid having the second cap launch out and unscrewing it here in the press is like as good a way as I could come up with. I just have some snap ring pliers so we have like a right angle way to turn it. And I'm just going to keep winding the ram up and down and just kind of just back it up, I guess. And then hopefully when it comes free, it just pops up into that. We've totally lost that other cap. I can't find it. So we really need this one so we can machine another one to put this back together. I can't make a full turn because of this shaft here. Man, these springs are stout. It's still pushing harder than I can push it down. Ah, much better. So yes, somewhere over in the pile of Mini Mac parts in the shop is another one of these, and I need to keep looking or make one. I'd rather not have to make that, but it wouldn't be impossible if we do. And you can see here this spring is intact, so at least we can measure it and try to come up with another one of these for the other side since it was destroyed. These are both in good shape. Now I'm going to try to wash these bores out. We can get those pistons out. Alrighty guys, I got everything torn apart. We cleaned up all of our gasket surfaces, mostly just with scrapers. Cleaned them up in the parts washer. And at this point, we're ready to start making gaskets so that we can go back together. Now I also have the problem here when we took apart the first set of springs, we lost one of these guys, and it is somewhere in this shop. And I need to clean up around Mini Mac anyway, so we can start working on that a little bit. But we may end up machining one of these because it is gone. And at this point, I want to start making gaskets. We could start putting this guy back together. I apologize, I'm trying to make a cohesive story here for you because this has been a little bit of time delay since we got it running, and we've been out trucking with the Ford and everything else, and yeah, sometimes making a story go in a storyline for a video can be a little bit of a challenge. So we're going to start cutting gaskets. We need to maybe machine this, find this part, put this governor back together, get the governor working. There's a few other little leaks, hoses, things we need to take care of, and then we're going to start seeing if we can make some power. This gasket material has like reinforcement in it too, so it cuts a little bit harder than some. So this is the gear pump that runs the oil for this hydraulic governor. And the thing I'm concerned with here is whatever thickness gasket we put in is essentially adding side clearance to these gears, which is going to make oil slip and make things less efficient, you know, everything like that. So what I was trying to see here was if we're around 0 there, it's like a 1/2,000 short of basically the sidewall, and so is this side. So no gasket would have a 1/2 thou clearance, and this is just flat here, and you can see the gear, you know, for however many years was just kind of parked there. So no gasket at all would have basically a 1/2,000 side clearance on this gear pump. So whatever thickness gasket we put on is widening that gap from that point. This stuff is like 38 thousandths, and this is like 30 thousandths. I was trying to measure the thickness of the bottom gasket. It's like 20 thousandths. I need to do a little research. I don't know how much side clearance a gear pump typically has, but I would think you'd only want maybe like a few thousandths, maybe like 5. That seems like an awfully thin gasket here though. So let's do a little research on that and what thickness material we need. I kind of think everything I have is too thick. I should have kept to be able to measure what I took off of here, and I didn't. I have searched high and low for this plug's friend that I lost when I took it apart and launched everything out of this governor, and I can't find it anywhere. I have moved everything under this truck. I have gone through everything on these shelves. It's helped because we've been cleaning up as we've been doing this. But I have no idea. You know, like the minute we make it, we're gonna find it. But at this point, we have to make it because we need another one of these plugs. So this part here is the actual miniature hydraulic cylinder. The seals are good and tight on this, so hopefully it doesn't leak. Good and tight. But we basically, that's a little seal backup washer there. That guy gets mashed when this guy bolts in. But the hydraulic oil from that gear pump, and this is all internal. This doesn't use engine oil at all. It has its own reservoir, its own little gear pump. And basically for more throttle, it pulls it in, and for less throttle, it pushes it back. So the shutdown position on the engine is with, you know, you override all this with that manual lever I was using earlier, but all the way out, that's shut down, and then as it calls for more fuel, it's pulling in. This is more or less directly controlling the rack. There's springs so that you can override it with the hand throttle, but during normal operation, when you put that hand lever in run, this has full control over the 3 racks, the rack in each unit injector up in the valve train. So if something were to go wrong in here and this guy gets stuck, whatever, that's where the overspeed trip comes in. That's like a whole secondary system on the engine to shut itself down and prevent a runaway from happening. So I gotta say, with messing with this whole governor, tearing this whole thing apart, I'm glad that the automatic shutdown exists. I'm just using engine oil as our pre-lube on all this. So this diameter seats here, and then there's basically another diameter a little bit lower down there. And that is a little bit rough. I have to test this. Make sure nothing's stuck. Doesn't feel bad. All right, so we cleaned up the bolts, socket head cap screws. Just gonna give each of them just a little dab of C's. So I think that all that you have happening here with the springs in these pistons is they're like a pulsation dampener. They can absorb the changes, and I think that's all they really do, is they're kind of like an accumulator, more or less. And I'm gonna pull the little adjuster motor out of this guy now. Like a secret handshake, I think, to come out of here. There it is. Huh. A 1940s gear motor. That's cool. Really don't want to be super aggressive on this. Just want to kind of clean up those rust streaks. Maybe just a little bit of polish, kind of buff it out a little bit. So I wasn't filming this real life, but you know, I've been looking for the other one of these plugs that screw in here, and I was opening this looking for a remover, and look what it is! It's the other plug. It must have bounced off me and into the drawer, and I hadn't noticed it. Oh, saves us machining a new one. Great success! On a side note, did a little polishing on our tag here. Look at that. Sweet. Alrighty, well, since we found that other plug, I think that means it's only time to try to reassemble this thing. You can see that's a long way to go. That has to be there, and then luckily they do give you that little shoulder to help start this, but still you got to start it without cross-threading it, and that's going to be kind of difficult, I think. As far as the broken spring, I'm having trouble finding a spring that dimension. And I guess honestly, I question how much they're squishing it, because the ones I did find that were 8-inch free length like this have a max of 4-inch, which is basically where this lives before there's any more compression. So I guess we're just going to try it without that. Just put the broken spring back in. So this side will have a little less force but the same spring rate, and that just means that plunger will live a little further down than it would have. So I don't know. If we have any crazy issues, I guess that'll be our first thing to try. We'll put the broken spring on the side with the piston for our own future reference here. And let's go to the press and try to put this together. Well, who's taking bets on how many times we can launch this across the shop? Let's get her started down in there. So this is just the adjustment on the press. This isn't really obviously how the press would be used, but you have a nice amount of feel doing it like this. Maybe the next step up, Cobras. This is just such a fine line to walk of following the spring force, not hurting the thread, not cross-threading, not pushing too hard. Has it started? Oh, it is started. Oh God, this is like a bomb ready to go off. Official devices. So I didn't push it down with these because I was afraid that we'd end up kind of off center. All right, that worked though. Awesome. Here's one. All right, we're going to try out the Governor speed adjust motor with AC. It says 115 AC DC. I'm not sure how this is going to go. We might let the smoke out of the box, but I hooked neutral up to 1 because it's the red one. I hooked hot up to 2, and I'm assuming that's, one way. And if you move the hot to the other lead, that will go the other way, but I don't know that. It could smoke. All righty, let's see if we let the smoke out. Oh yeah, it's not happy. Or maybe that is it. It's turning. Oh yeah, it's only 10 RPM, I guess, huh? All right, so that's that direction. It smells like a Lionel train. All right, we'll get her switched around here. Does it go the other way? No. These wire nuts are about 58 times too big. All right, give her one more try there. Nope. Maybe red is hot. Nope. Did we trip the breaker yet? Maybe you stay on 2 and run 1 or 3. That's the only combo we haven't tried. 2 and 3. Nothing on 1. Oh, there it is. So 2 is your common, and you either put power on 1 or 3 to reverse it. And we have a remote controllable 1944 Cleveland. All right, motor's back in its home. Wiring, that's going to be a future us problem. I did notice some advertising for these guys on eBay. Oh man, that polished up cover already looks sweet. I'll figure out what we're going to do with this guy. So I hammered this gasket out. That's what we're going to use on this sealing surface here. The top cover I still need to clean up. I don't know, it's covered. This gasket's probably good enough for who it's for though. I'm just going to leave this gasket dry because there's a high likelihood this is going to have to come back apart, and we'll make that easier on ourselves. So next, this is our little flyweight set up here for the governor so it knows how fast it's going. I'm just going to put a little pre-lubage on. That guy just drops down over here. That's what that coupler drive shaft drove, so that the input gets run up here to the top. And now, without further ado, we should be ready for this whole top apparatus. This is the back of the engine, so that means the control faces this way. The only tricky thing to this is this droop detection lever here, which basically senses how far the little hydraulic cylinder moves. We have to put that in the groove of the hydraulic cylinder, so we're definitely going to have to pay attention to that guy. Okay, it's in the groove. So this is the valve that actually controls what's happening in here. Not sure if we can sneak him around or not. It's gonna be hard / impossible. Go a long way on this fella. Also, I need to see if it's in that manual, but I'm assuming we just want engine oil in this thing. Don't think that's going to happen. We don't want to hurt that. And that sits like that. Yeah. Round 38. So we started this there a minute ago. Now we can wind it all the way back up in here where it belongs. As this pushes down and pushes harder against those flyweights, that's what increases the throttle, increases the RPM it runs at. And basically it's just modulating that valve up and down, which that in turn runs this hydraulic cylinder. This is the droop adjustment, so as you turn this screw, it moves that up and down for basically how sensitive the force on the spring backs off as it moves the hydraulic cylinder out. So I was just looking for some 40 weight, and I think I found some. Oh, yep, there's my 40 weight. Let's put her in. How can we drive you? I wish I could claim all the genius for this idea, but this is Big John's idea. We're going to take a piece of 5/8 heater hose. We got our 5/8 bolt, and we can just run this with an impact. And we're just going to slip this up here over the shaft and give her a tighten. And hopefully we can try to run the governor. I really think that ought to be pushing out on that cylinder. Oh, heater hose just wasn't meant for it. Drained a little bit of oil out, and I've also converted us using a socket head cap screw to a 1/2 inch thread, so I should be able to grab it with the old drill. I think that'll be easier on the hose than the 1/2 inch Impacto Dacto. Yeah, I think the drill is much better. It's pretty strong. Oh my God. I'm gonna die. Being pushed to the limit. And there she is. Time for hernia surgery. But if the governor isn't where you want it and you need to override it, that's where the spring comes into play. So like to shut down, when you slow down the RPM, the governor's gonna suck in and give it full throttle. So you can override that by being able to shut it down with the handle pulling that spring out. Short one goes up front here, because it has to. Next little issue we need to address are the hoses that run from the isolation valves up to the gauges here. These are our different oil pressures. Basically, we have 4 different readings. So there's before and after the strainer, and then there's inlet of the engine and outlet of the engine, where it's kind of like the front and back of the gallery, I guess you would say. But these are dual needle gauges. You can shut these needle valves here to kind of isolate them. I don't know why they're not just a ball valve, but you know, they're needle valve. Anyway, these poor antique rubber lines are rotted out between these valves and the gauges, so that was leaking some oil when we were running it before. I'm going to pull them out so we can take them to the hydraulic shop and get some new ones made. So after talking to our local hydraulic shop, there's some great guys over there I really trust about, you know, what is the best way to go about recreating these hoses. They told me they have this 300 PSI hose with these push to connect connectors, and you don't need hose clamps with these, I guess. I've never used them, but we have one side that's a JIC-4 JIC, and then just a 1/4 inch to JIC adapter. And then the other side is just a straight 1/4 inch male thread to hose barb. So we're gonna try to make some of these guys up here on the bench. It might be easier just to make them up in place. I don't know, but we'll just push this on. It's good to like 300 PSI. It's really nice and flexible. So I think this is gonna work well for us. It's a real similar diameter to what was there before. So I think it'll look the part anyhow. So this is the male NPT to hose barb, and we can see it's just about the same as that. So we just want to cut this hose just about the same spot Maybe just a hair longer. And we'll just stick that in there. And there she is. Our new version of that guy. Well, that is super nice. Now we're nice and new and flexible. I like it. Let's do it 6 more times. Right back. Beep. Take 2. There we go. Put a little of this sauce on there. And then each one of these gauges needs one of these adapter kits. If I could get it started. There we go. Need the sauce. I'm a little concerned about starting this. I hope this isn't impossible to do. Not bad at all. Reach in there and give her a little Titan package. And that guy will be that guy. That's perfect. I really like that. That's nice. All right, you've seen one. Let's do the rest a little quicker. Well, I really like these hoses. And I think they're gonna hold a little more fluid than the last ones. That's what all that oil was. You guys could probably see in that first video. We had puddling up down here. Those hoses were kind of disintegrating. But now they're not. I really like those push connects. Maybe we'll cut all these plastic things. I don't know if they're supposed to get you to push it on there that far. I thought I had them all tight. That one's definitely got some wiggle. We can work that down, but I think I might cut those off just for the look of it. When we go to paint that, I'll just throw some masking tape, I'd say, down there at the bottom. So now we have our fuel situation a little better sorted. The next task is let's fix up our water supply so that we can at least fill this thing with water. We don't have a radiator figured out yet, but if we can at least fill the whole thing with water, I'll feel a lot better about it. The liners themselves on this are actually hollow. The water comes in the bottom from this manifold here, goes in the liners, up into the head, and then comes back out of the head through this box here and back down. So what I'm going to do is essentially block off the inlet and the outlet because this is a crossover, and you can manually override it with, to check again. There it is. So we put our garden hose connection on. Now normally this would be where it returns from the cooler, going back through the oil cooler up into the water pump. This is the exit to the cooler, or in our case it'll be exit to the radiator, through the radiator and back into this side. I really don't know which way I want this, because I think if it thinks it's cold, which it says colder is this way, that would be bypass. So if we put it to lower seat, I think that should make it recirc. Because as it gets hotter, that's when I want to send it to the cooler. So it's going to pull out and send it to the cooler. So there's kind of like two different things you can adjust. You can spin this guy, which that has something to do with changing where the thermostat side adjusts the seat to. And then this just kind of full manual override over here. It's just directly moving the seat. So I don't really know which way you want to go about this. I think I'm going to try to leave it down that way because that should let it recirc and not be trying to push it out to the non-existent cooler. I have this bleeder valve open up top here, but it does have a little bit of mud in it. I probably ought to grab something and clean that out. Both sides of this kind of water box are leaking where it comes out of the exhaust manifold. This side as well, so probably gonna have to remove that, make some new gaskets and reinstall it. Bleed the fuel through the pump once again. To the filters, I should say. Okay, there's fuel right there. Shut that bypass off. So that would have bled the fuel down here. As far as we can tell, filled all this up. It may have to crank a little, wouldn't be surprised. The main difference on starting this time is now the governor should work. Before it didn't. That reminds me, I think I forgot to put a lock nut on up there. Yep. I'm glad I remember that. It's one of those things you should never not finish doing it. From our 900 disassembly reassemblies. It's been a little while now since this thing ran. Really the last video you saw, last time it ran. So I just kind of gave it everything a quick once over. The exciter's still not hooked up. I do have stones. We get this thing running right. I want to try to clean up some of these things over here in the generator land. Oil level's good. We have water in it now. Shut our bleeder back off. The fuel's relatively bled. I'm going to open the doors, grab some earplugs, see if we can make some noise. I guess blocking off the water isn't the best idea. Well, 600 is a nice idle though. Another thing is we have no real expansion for it right now either. Take two. That must be the overspeed trip. I didn't think it sounded like we're going that fast. I guess that's why you need the old tack. But hey, it works, and we didn't throw a rod. Hey, let's pull a valve cover off and see if that little lever's underneath and the injector's stuck down like we think it should be. Yep. Then injector rocker's held up in the air. That's cool. So to reset our overspeed shutdown, it should just be pulling this lever. You know, you may have to do it while it's rolling over so the cam can push up on that. All right, so it's in. I bet if we just roll it over, it'll reset. I'm gonna lock the rack in the off position. Yep, and now they're working. So that's how our overspeed trip works. Awesome. We are just testing one system after another. And now it's no longer the untried AZ5 button. So I feel good that our overspeed's working. No idea if that was the 1400 RPM it's supposed to trip at. We need to get a tack, or at least we could put a reflective strip somewhere, or just check if we're making 60 hertz. All of these things will be ways to tell. So in the meantime, we're going to need to build a panel. I got the rheostat. I got a bigger resistor. I think I have it all planned out. How we control the field voltage in the exciter to control the armature output of the exciter to the field of the main generator. I have a plan, and I've got a lot of the parts either here or coming. That's going to be our next vid on this engine, is making some power. Actually wiring up that panel, I think we'll probably temporarily mount it because I want to build up a whole skid and it'll mount to that, as well as a fuel tank up above here and our radiator off to the front, whatever we end up with for that. So for now, we'll kind of temporarily put that panel together on the floor and see if we can get this thing to generate. But at least the overspeed works. Our water system needs a lot of attention. There's leaks everywhere. But we'll get to that. And but the governor is working. It's surged a little bit. I think I need to play with the adjustment of that needle and things like that inside of there. Not a huge deal. We can do that. I'm just very happy it has a governor now. Before it was kind of like it would speed up and it would slow down because it was just full manual control. And shutting it down now that linkage works seemed to be way easier when we shut it down earlier because it can actually stretch out to where it needs to be. Before I was like just pushing on that lever as hard as I could, and now we don't have to do that. So that's much happier. All good things. We are making progress on the old girl. Well, that turned out pretty well. I'm happy with everything that we're able to accomplish on this mission. We have a fully functioning governor. I think a little bit more tweaking to get some of the surging out of it, but that's no big deal. That's what some of the droop screws, the needle valves, I got to figure a little more out with that. I haven't really played with it here, but we really need to improve our cooling system. It's a delicate balance of basically opening the valve on the incoming water. You can see the geyser we had going here. That's because there's way too much pressure up in that top box. I don't think it's meant to be that way. So we need to get an actual radiator on here where we can let it cycle through the way it wants to and not be under pressure from itself. So that's on the list. In doing that, I want to basically get some steel and build a big skid, build some sort of structure here to put a fuel tank up above so that we have gravity-fed fuel. We'll mount our electrical panel that we're going to need to wire up on the back side or front side of that for the exciter and the generator control. And off the front side, we can put mounts for the radiator. So that's kind of all coming up. On top of that, I want to probably soda blast this thing. I think I'm either going to just hire that out or rent a soda blaster because all I have is a traditional dry sandblaster that we run Black Beauty in. I don't want to run Black Beauty on this engine. I think that's a bad idea. So we'll probably needle scale what we can just to save on media and time with the soda blaster. And then we'll hit it with that. A lot of the brass pieces, I think I want to leave brass. So once we get it all cleaned up, blasted, we'll mask off the brass, just paint some navy gray on everything that's left, and I think that'll make it look really sharp. So if you guys are interested in the old Cleveland, I think this thing is so cool. I bought it, I really didn't know why, and I've fallen in love with it, more or less. So we're going to keep going on this here this winter. We're also going to be getting back on the Mini Mac here very soon. I have more parts for it, and we're going to be jumping on that project because I want to get it done enough to drive, run, and be out of the way so we can work on the 50-ton lowboy this winter. All goals. I'm Sam with Scrappy Industries. Thanks for watching.